All right, I am going to start up. John, right now you're the only one here, I think. But we'll, as other people come in, that's not a problem. Can you see my screen, and do you see the screen with a big J on there right now?
Yes.
All right, if I go to here, now do you see my calendar?
Yeah.
All right, so I should be able to go in here and start. All right, give me a second here. There we go. So we're going to go over Chapter 4, but a couple things before we do. First thing, just so you know, you guys may know, may not know, may or may not care, there are 8 people signed up for this class. Out of the 8 people, 7 people yesterday sent me in something for their test. I will be grading the tests tonight. I have not looked at any of them. What I am going to do is tomorrow morning, when I start class, we're going to go over Chapter 5, but before we do, I'm probably going to take the first hour, and I'm going to pretend that I'm a student in this class, and I'm going to take the test. So literally, you'll be able to watch me taking the test. Now, 2 things about that. First of all, I'm normally not going to do that, but since it's the first test, I think that might be worthwhile. And secondly, that first hour will only be available on the Microsoft Teams link. I'm not going to also put that on Camtasia and put that out on my YouTube channel, because my test, although it's different than the test that Mr. Gudmested is giving at the St. Louis campus, it is very similar. So I don't want to, basically put a key out there on YouTube for people to look at. All right, and then finally, if you are the one person who did not turn a test in yesterday and you happen to be watching this video later, all right, if you turn it in by the time class starts tomorrow, I will give you partial credit. How much? Well, it depends on a lot of things. You'll lose points because you didn't turn it in on time, but I'd like to give you some credit. All right, if the person I'm talking to right now does not turn anything in by 8:05 a.m. tomorrow morning, they'll get a 0 on the test. And that I can't change because, like I said, I'll be going over it at that time. So, as always, if you have questions about things I'm saying, doing, etc., send me an email. We can have a Teams meeting together, one-on-one if we need to, but I've been getting a lot of emails and I try to answer them right away. All right? So, with that said, I'm jumping into Chapter 4 right now, which is how to work with numeric and string data. All right? And I believe I showed you this website before, but I do want to show it again. All right? And I'll put the URL up there and I'll make it bigger. And again, when I do stuff like this, it's not to waste my time, it's not to waste your time. But for lack of better words, this is almost what you'd call the quintessential resource for anything that's C#. And this is all you need. It's just the docs.microsoft.com. And that'll bring you out here. And you'll notice that if you go out there, there's a big search right near the top. So why am I telling you this? Because today we're going to talk about 2 different things, a few different things. But if I type in here, for example, C# data types, and I hit enter, all right, the C# type system, choosing the correct data type, etc. Let's try this built-in type, C# reference. So there they are. So if you want to do something with a data type and you're not sure what to do with it, etc., you can come out there and look at that. Another thing that we're going to look at today, all right, another thing that we're going to look at today in just a minute is we're going to look at the C# string data type and some of the stuff you can do with that. So there's strings, the C# programming guide. And I'm not saying that's going to give you everything that you need, but it's a great place to start. In fact, if you end up Googling it, you're probably going to, if you Google C# string data type, probably one of the ones at the top, if not at the top, is going to be this thing I'm showing you right now. We're also going to look at the numeric data types. So there's numbers. All right, enough of that, of the sermonizing, but I just wanted you to see that. So in this chapter, we're first going to talk about built-in value types. You can read the other stuff that's in here. Some of the stuff that's in here we've already gone over. It doesn't hurt to review it, so we'll go over it again. Some of the stuff down near the bottom of the chapter is more difficult. I'm telling you that right now. It will not be on your next test, but I want to show it to you anyway. So after we talk about the built-in value types, we'll get into strings. And then we'll talk about how to convert between data types. And guess what? You already know some of that because we've done the convert.toInt32 and the convert.toDecimal and the convert.toDouble, etc. So we've done some of that. All right, next we go into these three skills, and probably the hardest thing that we've done so far will be the stuff on page 124, talking about nullable value types and the null coalescing operator. We will go over it. I'm not going to spend a lot of time on it. You won't be tested on it. It's a fairly new feature that, depending on your situation, you may want to take advantage of. Then finally, as it says, the chapter ends with two versions of an invoice total application. So I think we've already written that, but we're going to take a look at it anyway. And the first one is just a single invoice. And with the next one, you can put in multiple invoices. It keeps track of how many you put in, what the average invoice is, what the total invoice is, etc. So we'll look at all that stuff in just a bit. As always, for those of you watching, and John, it might now be just you, but please feel free to, ask a question at any time if you have any. Okay, so it says to start with, we're going to show you how to use the built-in data types. Now, I'm going to turn to this page because there they are. You'll notice that, for instance, there's a byte and there's an S byte. There's a short and a U short, etc. The difference between these is if it has an S on it, it can be negative. So notice an S byte goes from negative 128 to positive 127, where a byte goes from 0 to 255. And I'm not going to read all of them. You can see the rest. But all of the ones that you see here that I'm about to at least try to put into gray, so everything up until float, so all that you can see that's in gray right now. So meaning the byte, the S byte, the short, the U short, the int, the U int, the long, and the U long, those are all whole numbers only. The difference between each one of those is the range. I'm not going to read that. You can see it in front of you. The float, the double, and the decimal, those three data types, and it's not letting me for whatever reason highlight those, but those three, so float, double, and decimal, those are all variables that can hold a decimal place. Notice that float is basically, it says with approximately significant digits. That means that you can be sure that it will be correct to within 7 digits. Here it's to within 14 digits, and here it's to within 28 digits. So again, you might say, well, what's the big difference? Well, if I was going to try to send something, if I was working for NASA and I wanted to make sure that the rocket that we were launching, let's just say it was an unmanned satellite that we wanted to put on Mars. All right, going to 7 significant digits may miss Mars, 14 may get you closer, where 28 may actually hit it. So it just depends on what it is you're trying to do. Virtually, for just about everything that we're doing in this class, double or decimal would be fine. Probably double would be fine for just about everything. All right, then you've got a char, and a char is a single character. Notice it says that it is a Unicode character. Back in the day, when I was your guys' age, we did not use what's called the Unicode Character Set. we used what was called the Ascii Character Set. All right, ASCII is an acronym, and it stands for American Standard Code for Information Interchange. At that time, the only types of keyboards and the only types of characters you really had to worry about were English characters. So in other words, this handled all national, we'll say, characters. Now, when it talks about a Unicode character, the Unicode character, for example, for some of these, you'll notice it looks like it's more than one character, and it is, but it represents just a single character. And if that doesn't make sense, don't let it throw you. The problem is, over time, we became not just a national society, but we became an international society. And even though the ASCII, or American Standard for Information or Code for Information Interchange, held 255 characters, pretty soon that wasn't enough. So we went to the Unicode character set. Now, they're not going to show it in there. Why? Because notice, there's almost 145,000 different characters. I believe the first 255 characters of that set are the ASCII character set. All right? Now, I have no idea. I would sure think, though, yeah, it doesn't show all of them. All right? But it also has the character sets for example, Japanese, Chinese, Spanish, etc. It has their character sets. All right? And so when you put in a Unicode character, something more or less like this, or let's just use, I don't know, grab something that, well, I guess they don't have any real values in here, but let's see. So, for example, if you want to put in a single character, it'll look more like this, is what I'm saying, if you use the Unicode character set. Do you have to worry about that? You really and truly shouldn't. All right? Again, I've always mentioned to you guys that on the left-hand side of the book is all text. On the right-hand side is usually code, or it's a table like this, or something else. And a lot of times, down at the bottom of the page, there is a summary of what was on the previous page. All right? And the last one, I guess I didn't mention, was Boolean. We've already used that in Bool. It's true-false. All right. How to declare and initialize variables? We've talked about this already. Again, if you don't know the value of your variable, if you don't know its value when you declare it, you typically just say this, int counter. If, later on in the program, then you can say counter equal 1. If you know the value at the beginning of the program, and you know it's 1, for example, then you would do this. You would say the int counter equal 1. All right? So to say int counter, as it says, that is a variable declaration. To say counter equal 1, that is a variable assignment. Putting them together means that you are both declaring the variable and assigning a value to it. And they're showing plenty of different examples here. They give their definition for a variable. I just said kind of look at it as a bucket or a container that holds information, and its value can change or vary while the program's executing. All right, that's about it. And this value that's to the right of the equal sign, so the 1 here, that's known as a numeric literal. So we are taking the numeric literal 1 and assigning it to the integer variable counter. And if you understand that, there really is nothing more to it than that. They do say you should have meaningful names. And this is an example here, or let's use interest rate, of what's called camel casing. It's 2 words, so you run them together. The first word is totally in lowercase. The first letter of the second word is in uppercase, and everything else is in lowercase. And if you wanted to call this current interest rate, for example, it would be the word current at the beginning. The I in interest there would be capitalized, and the R in rate would be capitalized. There's really not much more to it to say than that. All right. Constants, again, are values that cannot be changed while the program is running. Now, Muroc does not do this, but it is kind of been an unwritten standard in most programming languages for years that when you create a constant, you make it all in uppercase. Now, they're not using it all in uppercase. They're using what's called snake case. The difference between snake case and camel case is in snake case, the first letter of the first word is capitalized. I mean, to me, grabbing this, there's absolutely nothing wrong with what they're doing, and it'll work fine. But to put days in November into an integer constant and give it a value and put it all in caps sends a signal to me as a programmer, hey, that is a constant. Its value cannot change. So after we declare it and initialize it here, and you do declare it and initialize it together like this, after we do that, this constant can no longer appear on the left-hand side of an equal sign, or you'll get an error. All right, they call that Pascal notation. It goes by a lot of different names. Again, you should always use meaningful names, all right, whether it is a constant or a variable. And there are some books, just so you're aware of this, that will define a constant as a variable that cannot be changed, or a variable whose value cannot be changed. All right. So, arithmetic expressions. We've looked at a lot of these. All right. I'm going to show you a couple more of the ones on the bottom in just a second. But if I come through here, and let me do this. I'm going to just quickly dummy up something right here, and I'll make it nice and small. All right, so we can look at the stuff that's in here. So I'm going to move that up so I can move this up a little bit. You know that if I say, for example, int a equals 7, int b, in fact, let's give them better names than that. So let's go num1 is 7, and I'm just going to say num2 equals, let's say, 3. All right, now if I come in and say int sum equals num1 plus num2, and I'm not trying to insult anyone's intelligence, you know that that's going to be 10. No surprise there. If you say int, let's just say diff for the difference, equals num1 minus num2, all right, then that is going to be the difference of the two. So 7 minus 3, so that'll be 4. If we say int product, so prod, let's say, equals num1 times num2, that'll be 10, or 7 times 3, I should say, 21. If I say int and I want the quotient, and that is going to be num1 divided by num2. Now, you may think, well, that's going to give us like 2.33333. No, it's not. If you take an integer and divide it by another integer, a whole number, and divide it by another whole number, it just throws away the decimal place, and it's going to give you 2. Even if you make this a double, so even if I were to make that a double, it's now going to make it 2.0. So if you want to divide one integer by another integer and put the results into a double like this, then what you typically do, and I'm jumping ahead a couple pages, but you do what's called cast the integer. So I can come in here and say double like that. So I can either do that, or I can do this, or I can cast them both. It really and truly doesn't matter. Now, I believe that it's double in the parens and not in the number. You'll see in just a minute if I screwed up, but I don't think I did. That will give you 2.3333, etc. All right? So then we've got modulus, and that is the remainder operator. So if I said int mod equals num1 modulo num2, that says, what's 7 divided by 3? It is 2 with a remainder of 1. So that's the remainder operator. All right. You can when you declare a variable. So I'm going to make another variable here, and I'm going to say int num3, and I want to make it equal to 17. If it's 17 like this, you typically, literally 100 times out of 100, you do it like that. But that said, it is legal for you to put a plus sign there. I don't, for the life of me, know why you would do that, but you can do that. All right? And if it is negative, of course, you'd put a negative sign there. There shouldn't be anything new or surprising with that. All right? So let me take this, and I'm going to get rid of these. And like I said, that's review. Hopefully you understood all that stuff. All right? So I'm going to create two variables here, two more. I'm going to have int, and I'm going to call this num3 equals, we had our sum here, so int sum equals num1 plus num2, and we said that that was going to be equal to 10. No big surprise there. But I want to show you there is going to be a difference between doing this and saying int num3 equals plus plus sum and int num4 equals sum plus plus. These are the same operator, but they're used in two different ways. What this one does right here, all right, is first, let me put some space in here. It adds 1, plus plus or minus minus always add 1 or subtract 1, always. But this one first adds 1 to sum. So sum is now 11. Then it assigns the value of sum to num3. So in other words, both are now 11. Okay? All right. This one, on the other hand, I'll leave that up here. To do this, it reverses the order. In other words, this, just move these around. I'll make that a B, and I'll make that an A, and then I'll change the order. So this one first assigns the value, so they're not both 11. So num4 is 10. Sum is still 10, but after you do that, it adds 1 to it, so sum is now 11. All right? So I'm just going to ask this question, and you don't even have to answer unless, is there anything about that you don't understand? All right? And minus minus works the same way. So let's just change these both to minuses. So this subtracts 1 from sum. So sum is now 10. And then it assigns the value of sum to num3. So both are now 10. To say sum minus minus, this assigns the value of sum to n3. I guess it was, or to n4. So n4, or num4, is 11. Then it subtracts 1 from sum. So sum is now 10. Now, when you think about it that way, and I tried to give you a fairly complex example, or I should say a fairly big example, all right? If that confuses you, don't use it, all right? Another way to do this, if I want to add 1 to a variable, so I'm just going to get rid of everything I put in here. And if I want to add 1 to this variable, there's 4 ways I can do it. If all I want to do is add 1, the easiest way is to either say plus plus num1 or num1 plus plus, and in this case there's no difference between them, or I can do it the old bump and grind way, which says num1 equals num1 plus 1. That's the hardest way because it's the most typing. But as you're going to see in a couple pages, I can also say num1 plus equals 1. So if I want to add just 1, remember plus plus and minus minus only work to add 1 or subtract 1 from the variable. If I want to add any more than 1 to the variable, I cannot use this. Because I've had people do this before. They've tried saying num1 plus 7. That doesn't work and you'll get an error. On the other hand, if I want to add 7 to num1, I can say num1 equals num1 plus 7, or I can just say num1 plus equals 7, and virtually everyone uses that. And there's not only that, just so you know, before you even ask, there is plus equals, there is minus equals, there is times equals, there is divide equals, there is modulo equals. So you can use all of those different things in there. Or again, you could just say num1 equals num1 times or minus or divide or modulo. All right? Virtually you should never see this in code. Ever. So you might wonder, well, what about these? When do you see these in code? That'll be tomorrow's lecture because we're going to talk about loops tomorrow. All right? So that's it for what's shown on here. They give you an example similar to what I just did, so you can look at that. All right? Arithmetic expressions must always end with a semicolon at the end. Always. All right. These are known as binary operators because there must be something, these first 1, 2, 3, 4, 5. Those are binary operators because it means there must be something to the left of the plus sign and to the right of the plus sign. To the left of the minus sign, to the right of the minus sign, for all 5 of these. These operators that are right here are known as unary operators. They don't require something on the left and on the right. All right? And they mention that on the bottom of the page here, and that's why I brought it up. So how to code assignment statements? This is what I just showed you. So again, you can use plus equals, minus equals, times equals, divide equals, or modulo equals. All right, all of those work, and again, they give you several examples in here. All right, these go by different names. I mean, I've seen them in books called complex assignment operators. I don't think they're really complex. I've heard them called shorthand assignment operators. So again, there's a lot of different names that you'll see with those. All right, next is the order of precedence. And it's probably what you should have at least learned maybe in 8th grade math. That what you want to do, let's just look at these first. You do multiplication, division, and now our new modulus before you do addition and subtraction. So out of these 5 different binary operators, you do the first 3, the ones by number 3, before you do the last 2 by number 4. All right? The increment and decrement, so the plus plus and the minus minus are done, you know, depending on if I just showed you the difference between putting them before or after the variable. And the positive and negative is just changing a sign. As always, if you want to override the natural order, you use parentheses. All right? And that's what they say in here. There's nothing else really to this other than that. All right. Casting, I've shown you a little bit of. But there is an explicit cast like I showed you before. So let's look at these. If I say that, if I've got a grade that let's just say is 93.75, and I don't care about the decimal place, and I want to put it into an integer variable, I cast it to an int. Now, what that does is it throws away the decimal place. Even if that had been 93.99, it doesn't matter. It throws it away. All right, it just does a natural conversion. Now the next one is a little confusing. Char letter equals char 65. Well, what happens is the system goes into the character code. Remember, the first 255 things in the character code are the English keyboard, American keyboard, whatever you want to call it. 65 is a capital A. All right, and that would take a capital A and assign it to letter. If you go, well, that's confusing. Well, there probably is almost never going to be a reason to do this. All right. Then in the example here, they're adding A, B, and C, so 95, 86, and 91. All right, let's just do the math ourselves here off to the side. So they've got 95.0, which just is going to come up on 90, is 95 on here. And they're adding to that 86, and they're adding to that 91. Then they're dividing it by 3. And you can see, whoops, that was wrong. Let me try that again. So one more time, 95, and I can say the 0.0, it doesn't do anything. Adding to that the 86, adding to that the 91, which again gives us 272. Dividing 272 by 3 gives us that big number. All right? But what they're doing here, so rather than 90.666, etc., they're saying add these up and divide by 3, but take that sum and do the whole conversion and throw away the decimal place. All right? All right. If you want to keep it, you can cast it. There's a lot of different things that you can do here. Now, there are some rules on this. If I go from example, if I take a decimal and, a double and I cast it into a decimal, hopefully you remember from before, the double had 14 decimal places of accuracy, whereas the decimal had 28. That's called a widening conversion because I'm making it bigger than it used to be. There's also, if I go the other way and make it smaller, it's called a narrowing conversion, also known as an implicit or an explicit cast. And I do want to mention, because those words are important, and I just want you to see those, just in case, you probably know what they mean, but you may or may not know what they mean in the terms of most programming languages. And that's implicit versus explicit. All right? And if something is done explicitly, you do it. All right? So it's something, so if I go through there and add that, like it shows here, where I'm casting, I've done it. All right? On the other hand, when something is done implicitly, the computer does it. So in other words, it's done for you automatically, or as my friend Doug used to say, automagically. Some things are going to be done in most computer language implicitly. Some things in most computer languages, if you want them done, you have to do them explicitly yourself. All right. Like virtually any other programming language, C# has a math class. And again, we could have come in here and said the C# math class. Put that in, and there's the math class. Boom, you go there, and it'll show you, there's some examples, but somewhere in here, if you go down far enough, those are the different things that you can do in here. You'll notice it's alphabetized, and there's a few things. If you told me there's well over 100, I'd believe you. All right? But I want to give you two or three simple examples of when you might want to use the math class. I'm not even going to use theirs for now. I'm just going to use my own. So let me come in here and do those. All right. So I'm going to come in first and I'm going to say int age 1 equals 21. Int age 2 equals 65. All right. Int age diff equals, now if I say age 1 minus age 2, all right, it's going to give me what you think, and that is negative 44. On the other hand, if I do this, let's make this HDiff 1, and we'll make this HDiff 2. If I do this and I say age 2 minus age 1, it will then give me positive 44. Well, when doing an operation, a mathematical operation, if the sign is irrelevant, in other words, in this case it is. If I say, John, how old are you? And you say 21. And you say, Jeff, how old are you? And I say 65. There's 44 years between us. All right? So if I come in here and do this, and if I say math.abs, abs, and I put this in here, now it's going to throw away the sign, and it'll just give me 44. That's how you would typically use this. All right? Let's look at another example. Let's say that I say int num1, and I say it's equal to 5. All right? Then I want to say int num1, and I'm going to say squared, SQ. And I want to say, I could say it equals num1 times num1. Totally fine. And as you'd guess, it's going to give me 25. Then if I said again int num1 cubed, and I could say again num1 times num1 times num1. And that would give me 125. All totally legal, all totally legit. But what if I wanted, it'll be a big honking number, but what if I wanted num1 raised to the 9th power? So 5 times 5 times 5, 9 times. I could do this 9 more times. It'd be a pain in the butt, but I could do it. The easier way to do this is to say int num1 squared equals math.pow num1 2, which this line of code right here in line 12 will do the same thing as what you see in line 9. All right, putting this one in, and again, adding this to it, and making that a 3 will again now make that 125. So if I wanted to raise it to the 9th power, let's just say 2, 9 here. Oops, 2, 9. All right, and again, as I mentioned to you, I could do this. So that's what? There is 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would work. 1, 2, 3, 4, 5, 6, 7, 8, 9. But it's much easier to do that. So that's an example of using both the absolute value and the pow function. All right? Now, let's look quickly at another one of these. Then we're going to jump back into the book. So, what if I've got this number, 0.34567 All right? If I type in this, int num2 equals math.round, and I tell it to round num1, and I tell it to round it to 1 decimal place, now that is going to be equal to 5.3. All right? If I do it again, and I tell it to round it to 2 decimal places, it says, 3.45. So I've got to round up. So it'll be 5.35. And you can round to as many decimal places as you want to or need to do. All right? So I gave you round, and I guess it's a capital R, so I screwed up, sorry. So all of these, and it'll, the system would have found my error, but that should be a big R here, and that should be a big A there. I apologize for not making them in the correct caseness. Sorry about that. All right, but again, if you just look in your book, there's plenty of examples. These are neat. Min and max. All right? You can put in a lot of different stuff there, and it's a lot more powerful than it looks. We'll look at that in a later chapter. But just to show it to you, for the math.min and the math.max very quickly because I want to get out of this. So if I did this and I said int older equals math, what is it? Is it a capital M2? It probably is. Yep, sorry. So if int older equals math.max age 1, age 2, it'll look at those two values and say, well, age 2 is older because it's 65. On the other hand, if I do this, and you know where I'm going here, and I'll just call this, instead of older, I'll call it young, and I do a math.min, all right, it'll say age 1 because it's 21. Those are the major things that are in the math class that you will work with. There were other ones, all right? These are called static methods. What that means is you can call them without having to create your own special class like we've been doing. You can use the math class. In fact, when we say math.something, this says invoke the math class and then the round method of the math class. If that doesn't make a lot of sense to you, don't worry about it because chapters 12 through 16 are all about using classes and methods, etc. There's also a square root one. I really don't think I have to go over that because you understand square roots, I would guess. All right, the next one is neat because it's random numbers. And I want to quickly, again, jump back over to here and tell you about random numbers. If you run a random number program in virtually any programming language, any language, it doesn't matter if it's C# or not, by default, what you get is you get a number that is greater than or equal to 0 and less than 1. So basically the range is like 0 all the way through a bunch of 0.9999999. It's something like that. And that's in any programming language. So the random number that you get is a fractional number unless it's 0. All right? So let me check that mail quick. Nope, nobody else. All right. All right. So jumping back into our book then. When you do this, this is the first time we're seeing something that looks more object-oriented. They've created some shortcuts for you in C#. You have to put this, and typically you put this up at the top of your program where you create, for example, your constants. Random number equals new random. You can call this anything you want. It doesn't have to be number. You can call it R or RN for random number, whatever, or random with a little r. And then when you call the .next, notice by default it gives you something greater than or equal to 0 and less than the max value. The max value of a 32-bit integer is 9 billion something. So if you say number.next, it gives you a number between greater than or equal to 0 and less than 101. If you do the 1, this would be 1 because we're going to look at this in a bit. We're going to build a program after the break, all right? And that number that we're going to build, or that program rather, will generate a random number between 1 and 100, and then we'll have to guess it. And if we guess the random number, it'll tell us. We'll keep track of the number of guesses, and if we guess too high, we'll get a message that says too high. If we guess too low, we'll get a message that says too low. All right? You can also do it with doubles to get fractional numbers. All right. So this is all the stuff I mentioned to you before. It's got the fancy-dancy words, but it's all stuff we've already talked about. All right? Okay. That's it for numbers. So I'm going to ask this question again. If the answer is no, then just don't answer. Any questions on anything we just went over for numbers? All right, then I'm going to go on to strings, and around 9:15 or so, we will take a 10-minute break. All right? So I already showed you this, but again, if I come back in here to my docs.microsoft.com and I come in here and type in C# string data type and hit enter, and I go to this guide here, if I go down far enough, it's going to show me all of the different methods. There's some Unicode characters, just so you see them, okay? But all of the different methods that we're going to have, I know it's got to be in here someplace, to work with strings. It looks like, all right, related topics, let's see. How to modify, how to compare. All right, well, then I guess I lied to you, not on purpose. So if I go back again and I say C# string methods, all right, here says the basics of strings, how to search strings. Well, let's see if they have this. That's an actual Microsoft video. I don't know if it's good or not. I have no idea. All right, so I'm going to Google C# string methods. Somewhere it's going to give them to me. Here it is, the string class. All right, so if I go down in here long enough, I know you're going to show it to me. There they are. Properties, then methods. All right? So you can find those, and the reason I'm taking a couple minutes to explain that is not for filler, not to waste my time, not to waste your time, but to let you know that you're going to be working with strings on some of your assignments and on some of your homework problems. All right? So you might as well get used to knowing where to look if you've got a question or you can't remember to do something. All right. When you create a string, you already know this. String followed by the name, and then if you give it a value right away, you put it inside of double quotes. Nothing big there. Putting it double quote with nothing in between is setting it equal to the empty string, and setting it equal to null means unknown. All right? Okay. So, how do you join strings together? You use a plus sign. If we had said first name plus last name and didn't put that in there, that blank space, it would be Bob Smith with no space. Now, I'm going to show you something that we have not yet talked about, and that is this. You might look at this and, hey, you didn't do a .toString there, and guess what? It'll still work, even if you don't put a price.toString right there. But the recommendation is that you always include the .toString, which is why I've been doing it. All right, you can append strings, etc. And that's pretty much, you can use the plus equal operator. When you use it with strings, it doesn't mean add. It means concatenate. All right? You may have seen some of these characters right here before. I've used the \n before. That simulates you hitting the enter key on your keyboard. The only other one you'll probably ever use is the one below it, the \t. That's like hitting your tab key. I've never, in all my days as a programmer, I shouldn't say that. I have used the \r, but I've never used the other ones that I remember. All right? And again, those are called escape sequences. And this is, make sure when you do this, you use the \. And the \ is the character right up above your enter key on your keyboard. All right? So not the /, which is right to the left of your shift key. All right. How to convert data classes. Guess what? You've seen these already. We've done the convert.toSingle, not to single, but we've done the convert.toDouble. We've done the convert.toDecimal. We've done the convert.toInt32. There's really nothing new there. You've looked at a bunch of these convert methods previously. All right? Now, this is new. This thing that's got parse in here and try parse. These are new. Even if you go, we looked at them before, not like this. All right? So what we're going to do, not right now, but I've decided that I'm going to create this guessing game, and we're going to set up the guessing game so that if you put in either nothing for your guess, or you put in something non-numeric for your guess, or you put a guess in that's got a decimal place in it, we're going to show it an error message. All right, and we'll do that, like I said, in a little later. But you've done the 2 decimal, you've done the 2 double, you've done the 2 int 32. Boolean, we may have done that one even already anyway. All right, so those are the major ones. I've never used the 2 char. I haven't had a reason to that I can think of, and I've never used the 2 string itself, just the 2 string, other than the way we've used it. All right, how to use methods to convert numbers to formatted strings. And guess what? We've done this. We've done the C, and it can be upper or lowercase to convert something to currency. We've done the P for percentage, which can be upper or lowercase. And I've done the N, but I've always put a number in there afterwards, like N2 to mean 2 decimal places. I've never that I can think of used the float. I don't use the digits or the exponential or the general. So there's plenty of examples here on page 119 for you to take a look at. All right, the rest of the chapter, which I'm going to talk about right now, says 3 other skills for working with data. All right, and it's got here how to work with scope. All right, now they've got an example here. It's a fine example. There's nothing wrong with it. That said, I want to just quickly start up a new session of Visual Studio because I want to show you it, because it's a little hard to look at in the book, for lack of better words. So I'm going to come in here and I'm going to create a new project, and I'm just going to call it junk because that's all it's going to be. All right? So I'm going to make 2 of them. I'm going to call this first one junk 1. How about this? Junk 1 console. So you can see these both in console format. That's not there. I want to put in console there, of course. And I'm going to call this one, just so there's something there, I'm going to call it junk 1 console. All right, and I'm just going to call the solution junk, period, just junk. All right, not junk console, but just junk. All right, and click create. And then I get this. All right, there's a reason, there's a method for my madness. What I'm trying to show you is this. If I declare something up here, so any constants or variables that are declared here are what are referred to as global to the program. All right, and global also means known everywhere to the program. So in other words, if I come in here, first let's say I make a constant, and I'll say int, and I'll say inches in a foot, and I set that equal to 12. That means that main and any routines I write after main can use this, just naturally use it. And if I come in here and I say int inches equals 0, and I say int feet equals 0. All right, in fact, let's make that a double. You'll see why in a second. Or I could make it a decimal. It doesn't matter. That means if I come in here, I can say write, enter inches. All right, and then I'll say, I guess I'll have to say, put my using static system.console in here. All right, so now I've got that, and I can say inches equals, whoops, not that, inches, I don't want inches in a foot, I just want inches, equal, all right, let's see, inches equal, convert, I'll fix the error in a minute, dot toInt 32 read line. Now you might have noticed, or you probably noticed, it's giving me an error, and you're like, wait a minute, you just told me that it's global to the program, and it is. However, since I'm using main and main is static, I've got to use the word static here as well. And notice when I do that, now it works. The point is, I defined inches outside of any routine and I can use it in here. If I write another routine, so if I come in here and I write static void display, let's just say I call it that. It's a stupid name, but it's fine. And I want to come in here. Now notice if I say inches equal 26 as an example, I don't get an error. All right, so that's what's referred to as global scope. Now, let's not do that. Let's come in here and in fact, let me bring that back and remove it, and I'll bring it in here. All right, now I don't use the word static, but you'll notice that inches is now undefined in here. So I'm going to copy my comment here. Almost always, you will, when you define constants, you'll make them global. It's just programmers do that. But for this, any constants or variable that are declared here in a method, all right, those are local to the method, i.e., by default, only known to the method. Now, what if I want to make inches available to this method? What if I want to do that? Then I can say, okay, after I set it up, I can call display and I can pass in inches. Now, you'll notice it's now giving me two errors because it's over here, I'm passing in a variable, so it says I need to declare it down here. So I come in and I say int inches. And now everything is hunky-dory. But this is called passing a variable. I'm showing it to you now because I'm trying to demonstrate local scope to you. All right? And to do this, this must be called inches because that's the actual name. It's called the actual parameter name. Down here, this is called the formal name. I could just call it I. If I wanted to call it I here, I could do that. But then when I use it, I'd have to call it I. So just so you see this, all right, and I'm going to just quickly, I'm going to say write line in display inches equals, and I'm going to print out the value of I dot toString. And that should come in there, and it should say that it is 26. Now, I'm also going to come in here and print it out right here before I call the routine. So I'm going to say here, I'm in main. And it doesn't understand I because in main it's referred to as inches. So if I did this right and didn't screw it up, and we'll find out in a second, it should ask me to enter inches. I'll put in 12. And then it should say in main inches equal 12. Then it should come down and say in display inches equal 26, if I didn't screw anything up. All right, static system.console, why doesn't it like my read line? It doesn't because I need a semicolon at the end there. All right, so let me run this. So enter inches, 12. Again, in main, inches equal 12, but when I jump down, I changed its value in there. All right? Now, you might find this confusing, but I'm going to print it out again. All right, so I'm going to print out main again. Okay? So let me run it again here. And again, I'll put in 12. And it says 12. Now notice when I hit enter what happens. Oh, of course I didn't put in another read line. So let me put in that. And run it again. So I come in here, I say 12. Now notice, it's 12 again. Well, how did that happen? How did that happen? I changed the value here. No, I passed a copy of the value in and I changed the copy. If I want to change that permanently, then when I pass it in, I've got to use the word ref. And then in here, I have to use the word ref. All right? And why doesn't it like it? Maybe I did it backwards. It might be int ref, but I thought it was ref int. Int ref. No, it is ref int, so why doesn't it like it? We'll figure it out quickly. All right. Extract base class. Don't know why. There's something in there that it doesn't like, but that is how you do it. If we did that, then it would come back and it would be 26 in here when we got back. We're going to go over that in a later chapter. Probably confused you, and I didn't mean to do so. The last thing is, if I come in here and I write an if statement, and if I write if int, I can't do it like that, but if let's say if I write this, if inches, all right, if inches in a foot greater than 0, fine. So, and it is. But if I write that and I come in here now and I type in this, int hello equals 27. All right, so now I can come in here and do a write line of hello. All right, and if that works, and it should, all right, that should work without any problem. Read line, sorry. That should work, and it should print out 27. Let's see if it does. There's the 27, and there I'm back in. Okay, good. Now, the reason I'm showing you that is, what if I come outside of the if statement, and I type in hello equals 33? I get an error. C# is what's known as a block scope language, so if I define something within curly braces like this, it's only known within those curly braces. It's not known outside of the curly braces. So that, if you define a variable within curly braces, it has what is known as block scope. In other words, its value is only known between the curly braces. Now that's a lot more than they gave you in the book, but I found this diagram to be a little bit confusing. Hopefully what I showed you was a little better and not confusing. And if it was, I apologize in advance. It is 9:14. We really don't have much to go in the chapter. So we're going to take a break, and then after the break, we're going to write that program. I do not have it pre-written, so there's a good chance I'll screw it up as we're making it, but that's fine. You know, we'll all learn together, but after the break, we'll talk about enumerations and the like. So I'm going to put up my 10-minute timer. So your break starts now. See you in 10 minutes. Moment, so let me start this back up. All right. All right, so we left off, and now we're going to talk about enumerations. Just to give you a one-sentence definition of an enumeration is a user-defined variable type. So you can make your own variable type. All right? What does that mean? Let's take a look at some examples here. So here we've got a new variable type. The type is called term values, and it's a short integer, so it's a smaller integer, and it has 3 values. It's got net days 30, which is 30, net days 60, which is 60, and net 60 days and net 90 days. All right. Now, technically what happens is that in virtually any programming language that I know, is that the language will go and it'll make these all integers, and this will be integer 0, integer 1, and integer 2. You don't have to worry about that at all. All right? But what you're doing here is you're creating a new data type. Now, this example may or may not make sense. So let's talk about how else you could use this. We could make an enumeration and call it days of the week. It could hold strings, and I could have basically in here I could set day 1 equal to Sunday, day 2 equal to Monday, etc. if I wanted to do that. So what it does is it's creating constants. All right, that's why they're using that casing. Again, I would have made mine all in uppercase. They don't do that. Each constant is known as a member of an enumeration. It starts with 0. All right, there's a little bit more to it than that, but I don't know if we're going to have any occasion to use this at all, to be honest with you, all semester. All right, now the next page or two, I think it's just 124 and 125. Let's see. Yep. All right, so these 2 pages are probably the hardest 2 pages that we've had in the textbook thus far. So it's down up to page 124. All right, it says by default value data types, so anything that's not a string, an int, a decimal, a Boolean, etc., cannot store nulls. But because they hold values. Reference types, and if you say, I don't know what those are, you don't have to worry about it. The thing is, strings can hold nulls. It says there's a feature of C# called nullable types that allows you to store a null value in anything. And they're going to show you that. All right, if I come into my program that I had up here before, the one that I showed you, the one we were working on here. All right, and I'm going to get rid of all this stuff that I've got in here because I don't need any of it anymore. In fact, I don't even need that routine. I'll just have everything in main. If I want to create a brand new string, let me get rid of the comments and everything else in here and just shorten this out way out here. So if I come through here and I want to create a string, and I want to say string name equals, and I don't know what the name is yet, I can set it equal to the empty string and it'll work just fine. So later on in my program, I can say string equals, no, let's do it like this. We'll say write, enter your name. You've done this before. And then we say name equals readline. And that'll work just fine. There's no errors in there. You can see that. It looks great. I can also come in, and if I don't know the name for a person, I can put in there the word null. And there's still not a problem with it. Now, let's say that I want to also enter age. So I'm going to say int age, and we'll just here set it equal to 0. All right, now we come in here and we say write, enter your age. Now, you already know this, but if I try saying age equal readline, I'm going to get an error right away. Because what I'm attempting to do is to take a string and throw it into a number, which you can't do. But I can come in and do the convert dot to int 32, and it's giving me that error because that O is capitalized. It did, the IntelliSense didn't kick in right there. All right, but that'll work. Again, no error, that's totally fine. But what I cannot do is I cannot come in and say, hey, I don't know the value of age, so I'm going to put null in there. Notice when I do that, I get an error. And it says cannot convert null to int because int is what's referred to as a non-nullable type, where string is a nullable type. So how do I get around that? Well, notice what you can put here. So I can come in and I can say, what was it? Make sure I'm giving it to you right, otherwise I'm going to get an error. I can say int question mark, and notice now it goes away. All that means is it is permissible now for age to hold a value of null. That is permissible. That's what the question mark does, is it will take any type of variable that cannot normally hold null and allow it to hold null. I mean, that's basically the idea behind using this. All right. Then if you want to check afterwards to see, as you can see here, there's two properties for working with nullable values. One is has value. Anytime you start a variable, or just about any time with has or is, etc., it's going to be a Boolean. So this returns true if that would hold a value, and false if it does not. And value returns the actual value. So these are built-in types. Notice they're in capital letters, so they're in that other casing, the Pascal as the author called it. And here's an example of how to use it. All right. Now, it gets more difficult because look at this. There's another one you can use, so we just looked at it with a single question mark. You can also use it with the double question mark, where this is declaring something that can contain nulls that normally would not. This is called the null coalescing value. So let's back up for a second. So I showed you how to declare the nullable type. All right. And then down towards the bottom here, it says another way to test the value of a nullable type is to use the null coalescing operator. Again, it is two question marks. So it says in the figure, the value of 0, 0 will be assigned only if total is null. So if we did this and set it equal and it was null, all right, this is basically saying if that quantity was equal to, all right, if it here, use this one. If this was equal then to null, then set it to -1, otherwise leave it to what it was. Now, my explanation stunk. Their examples are okay, but if you want to really know how this is used, you'd start by looking on the bottom of the screen here and then mapping it up to the examples that are up higher in the screen, all right? And then if you still had questions, you'd go out to docs.microsoft.com and take a look. All right. Let's look at the last thing that's in the chapter, which is going to show two versions of this total invoice form. All right. We've already written something like this before, but there are going to be a few, as far as I remember, there'll be a few changes in it. All right, like what? Well, they're doing the convert to decimal, which I think we did before. All right, so I really probably there's nothing, I'm guessing at least, there's nothing in here that you don't already understand. At least that's my hope. This is grabbing whatever we put into that text box, which is the only one that we're inputting into. This is taking that value and attempting to convert it to a decimal. If it works, we multiply it by 0.25m to get the discount, which goes here. All right. And, I'm sorry, that's the discount percent. The discount amount takes whatever we put there, multiplies it by 25% and puts that there. Then we take the original price, subtract the discount from it, and that's our total. That's nothing new. We've looked at that before. But what they do next is they make an enhanced version of this. So if you look at it, now we can put multiple ones in here. Now they brought in a clear button, which I've already had you using. All right. So every time, so I come in here and I put in 225.5, I click calculate. I get all this. This will then say 1. This will say my total, which will be that. All right, etc., that kind of a thing. And then I can click clear and put in another one. The number of invoices will be 2. I will add up the sum. So this first one was this, or let's say this is the last one. All right, let's say the first one was 700 something. Then we'd add this, and we'd get that, and then we divide them by one another to get the average. All right? Now, when you look at this in here, I don't think there's anything that's in there that's really confusing. I didn't particularly like the example, so like I said, I'm going to build a different one for you right now. What I will do is eventually in fact, let's do it now. I'm going to go out to my GitHub account. All right. And I'm going to create a new repository right there. And there it is. And I'm going to call it, I think it'll take a sharp sign, but we'll find out. C#. All right. No, it doesn't so I'll put C# GG for C# guessing game. I'm going to make it public so everybody who wants to can look at it if they do want to. Yours, again, should always remain private. But I want to keep that name, so there it is. And I'm just going to go all the way down to the bottom and click Create Repository, and there it is. Okay? Now, before I do anything, I'm going to go and create a new project, so I'm going to start up Visual Studio. In fact, I'll use this one. Let me close the project. I'll just exit. No, I don't need to save that. That's just garbage anyway. So I'm going to start up a new session of Visual Studio. Here it is. And I'm going to make this I'm going to create a new project, and I'm going to make it a Windows Forms. You might have noticed, too, that the ones I've used recently, so I can come over here and choose Windows Forms as well. Okay. So I'm going to call this the same thing. So it's C# GG for C# guessing game. It's the only program I'm going to put in here. All right. So I'm going to leave it with that name. Okay. It's on the desktop automatically. So I'm just going to click Create. All right. And I'm going to mimic, for lack of better words, I don't know what happened there, but click Create. Maybe I didn't. All right. I'm going to mimic in there what happened in our book in here. All right, so I'll play a few games. I'll have my total number of games. I'll have my total number of guesses, and I'll have my guess average. All right, hopefully what I'm saying makes sense. I'm going to have a very simple interface. It'll say here, enter a number, and then down here, it'll say either too low, too high. If I leave it blank, it'll say can't be blank. And if I put in something out of range, because the range will be 0 to 100, it'll say out of range. That'll be the whole thing. All right? So I'm going to quickly try to build that for you right now. So I'm in here. I guess I'm, again, in a colorful mood. So I'm going to change my back color, and today I'll make it turquoise. There it is. All right. So I'm going to come in, and first of all, I'll add my buttons, the ones we normally add. So I'm going to add my clear button first. I'm sorry, my calculate button first. As always, in fact, let's just add everything later. So that'll be my clear button, and there will be my exit button. Looks like I spaced them out decently. All right, then I'm going to come in here, and I'm going to put in 2 labels. And the first one will be called LBL Guess. All right, and it'll be the guess that I'm making. And I will put in text for this that says, guess a number between 1 and 100. There that is. All right, and let's just copy that and I'll call this result. Not a great name, but it's fine. So I'll make that LBL result. All right. And let's see. I want to get the game working first, then we'll put the totals in after that. So I'm going to change this to just result. All right, so I've got all that done. That's good. Now, I want to add in 2 text boxes. That'll be my guess. And that'll be whatever I want the result to say. That I'm going to make bigger. In fact, I'll make them both bigger. There we go. Now I'm going to highlight everything, Control A. I'm going to go down to where I've got my font. And as I always do, I'm going to come in and set the size to 16, make it bold, make it Arial, and boom. Now I've got that. Okay. Looking at this, I'm almost ready. Let me move this over just a little bit. So there we go. I'm going to move these up. All right. I'm going to end up changing this in a little bit, but for now, this is going to be my whole program. All right. Now I want to do these, and I want to set the auto size on here. All right. And not sure what happened, but I'm going to make them, they'll both come back in a second. Come on. So guess a number between 1 and 100. There that is. And result, there that is. I want to right justify both of those. So there that is. All right, that's pretty much my interface. Okay, I've got to change names and stuff, but Control A to highlight them all, right mouse click, and lock controls. My interface is now locked into place. All right, this is LBL guess. This is LBL result, so this will become TXT right there. TXT guess, and TXT result. All right, this will become BTN calculate. And I will put the text in there as calculate. This will be BTN clear. And we'll put in here clear. And finally, this will be BTN exit. And we will put in here exit. All right, so there's my whole interface is now built. And let's change the name of the form. So I'm going to right mouse click on the name of the form here, which is form1.cs. And I'll just change it to FRM guessing game. All right. Yes, I want to change everything. So there we go. Whoop, didn't like something. Show the call stack. I had this happen before, and I hate that. So let's see. I don't know what I did. I might have pressed no, so I don't know what I did. Doggone it. Get call stack. Help. That service is unavailable. Oh, I hate this, and it just says I've got to fix that error, and I don't remember what that error was. And that's on me. So, let's see. Well, what I'm going to do is I'm going to totally get rid of this and redo it. All right, so it's gone. I'm going to recreate it. Add new project. Sorry about this, but it'll take me literally. I'll do it fast, so I don't have to explain what I did before. So, up, and I want to do that. And this will again be called whatever I called it before. We'll just call it guessing game. All right, and that's fine. So we've got a guessing game. It's created where it should be, and it's called guessing game. I apologize for this, but again, I will quickly recreate it. All right, so there's my buttons. There's my labels. And there's my text boxes. Okay. Again, I'll move this up for now. Shorten this up. We'll lock this into place. I don't want to lock it yet, but we will size everything. All right, so it's now all sized. The only thing I have to do then is to quickly, all right, and again, I'll make this even simpler. Again, this will be LBL guess. I think that's what I called it before. And I wrote LGL. LBL guess. All right, and the text on it will say enter number 1 through 100. Nice and short. There's that, and we'll move that over, and we'll just call this again LBL result, and I'll have it say result. All right, so I've got my interface. Basically now it's built good. All right, so I've got that named. I've got that named. Let's lock our interface into place. Let's quickly change the color. All right, so that's all fine. This will be TXT result. This, no, I'm sorry, that's the other one. This is TXT guess. This one is TXT result. This is BTN calculate. And we will put the text in there as calculate. This will have the text of clear. And it will have the text, it will have the name of BTN clear. And finally, this one will be BTN exit. And it will have the text of exit. All right, again, I will change the name of my form, so I will right mouse click, and I will rename it. In fact, let's not, because that's where it got goofed up, so I'll just leave it for now. Let's double check and make sure everything's been renamed, everything but the form was, and that's fine. All right, so what I want to do is I want to set it up so that when I click here, I put a number in there and I click here. If I put nothing in there, I want this to say nothing inputted. If I click in here and if I put in something that's non-integer, all right, I want this to say non-numeric value entered. If I put a number in here that's too big, greater than 100 or less than 1, I want it to say out of range guess. If I put in a number that is within range, like 6, and it's too low, I want that to say too low. If I put in 60 here and it's too high, I want it to say too high. If I put in 33 here and that's the number, I want it to say you guessed the number. All right, hopefully all that makes sense. So that'll be what we put into calculate in just a moment. Clear will do in just a second, and exit will do in just a second. And hopefully, even though I screwed it up doing it the first time, good, you had no problem with that. So as we're doing this, let's come in and first, because I always forget it and I want to give you the right stuff, I come in here and type in exit, and I've got my exit code. This is the same stuff I gave you in that email. It's the same email. All right, then I'm going to come in here and put that in for my exit button. I'm not going to worry about putting comments, etc. in here right now. So I can do a file, save all, and make sure that works. All right. I still have to center it, set my accept button, etc. We'll do that in a bit. Didn't like what I did, so let me try that again. Start it. All right, so the exit is working. Okay, for clear, and set the focus, let's first let's leave that, right now let's not make that read-only so we can test this right away. So for clear, I want to say txt guess dot text equals double quote txt result dot text equals double quote txt guess dot focus. All right, that should be my whole thing here. Let's save all again. Remember, when you do a save all, it's Control-Shift-S or a save all. Run this again. Now if I put a value in here and a value in here, click clear, they both cleared and my cursor is blinking in there. So the first two already work. All right, let's go back and make our changes we usually make in that. Let's make this field read only. So I'm highlighting the result field and I am putting in there, I'm finding read only and double clicking so that's true. All right, let's set the tab order. So I'll put my mouse in here right away and I'm going to do a view tab order, and that will be 0, 1, 2, 3, 4, 5, 6. So the tab order has been set. I can view the tab order again to make that go away. Click on here, set my accept button to btn calculate, set my cancel button to btn clear, and set my Windows or my start position to center screen. All right, I can very quickly just see if this works. I'm going to come here for the message box. I'm just going to put a message box dot show. I'm just going to have it say hello. All right, method to my madness. If you give me just a second here, I'm going to run it. And notice it's now centered. I can put something in here. I can click calculate and I get my hello. I can put something in there and hit enter. I'm leaving my cursor right there and that works. I can click clear and that worked. I can put something in here and leave my mouse there and hit escape and that works. I can do an exit and that works. So everything's working right now. So the only thing I have to do then is to actually put the right code into my calculate routine. All right, we're going to do this again a little bit differently. First thing I'm going to do is I'm going to create some constants up at the top of the program. And the first thing I'm going to put in here is, so I'm going to declare and initialize my program constants. All right, and I'm going to have probably about 5 or 6. The first will be const int, and I'll call it min guess, and that's going to be 1. Const int max guess, and that'll be 100. And that'll be both the smallest guess I can make and the largest guess I can make. And I'm going to have some strings too, so const string, and I'll call it too low, and I'll set that equal to guess was too low. And I'll have another one called too high. And it'll say guess was too high. Need my semicolon at the end of these, of course. I'll have another one that'll say empty. And that'll say no guess made. I'll have another one that will say NN guess, and that will say non-numeric guess. And finally, I'll have one more that'll say OOR guess, and that will say out of range guess. All right. Now, what doesn't it like here? Const requires that a value be provided. Oh, I didn't use my equal sign there. So that should have gotten rid of, let's see. Yep, all my errors are gone now. I'll pretty it up a little bit. So that's everything that I'm going to have. And again, this stuff is what is going to end up going in here, just so you're aware of that. Okay? All right. So getting there. So the first thing, what do I have to think about? Well, I'm going to need a guess. All right. So I'll have int guess, and I'll just set that equal to 0. I'll also have int num guesses. That'll be the number of guesses I have. And I'm going to set that equal to 0 because I haven't made any guesses yet. All right. So let's see. Will I need anything else? I think for now at least that'll be okay. But I do want to come in here and at the top of my program, you saw this before, I want to say random. All right. And I want that random number, so I'll call it, rand num, all right, equals new random. It's just something that you have to put in there. Now I can come in here and say int rand num equals next int 100. Now I can do that and it'll work and it's fine. All right, it doesn't like something, but we'll fix that in just a minute. But since I have those in here, min guess and max guess, I can also put those constants in there. So min guess and max guess. Now it doesn't like something that I did here, so what doesn't it like? It says the next int does not exist in the current context. Thought it was next int like that. All right, maybe it's... Well, let's look. I'm going to go back to the book. When in doubt, go back to the book. Let's see. Go back to about page 115. Just guessing here. No, it was before that. There we go. All right. Oh, it's just next. It's not next int. My error. Apologize. So it's just next. And that still doesn't like it. Oh, okay. Got it. Try to get rid of that. Bring up the right one. There we go. So that should be randnum.next, and I don't want to call this the same as this. I'll just call this rand equals that. That will then create a random number for me. All right? Now, if I want to prove that, it wouldn't make the game very fun, but I could just do a message box dot show, and I could put in there rand, or rand is plus rand. All right, and I won't put anything in there. So with what I've got now, if I run the program again, and I don't, if I run it and, well, I'm going to enter a guess, that's fine, but if I just put a 34 and I click calculate, there's the number. So that's the random number that was generated. All right. Now, what I'll do is I won't show that number, but we can put it in there later, or put another button in called hint, or whatever we want to do. That's fine. So we've got the number. Okay. So what I want to say here is guess equals convert dot to int 32. We're going to change this in just a moment, but txt guess dot text. All right. Now, this will work as long as I do put in a number. So I'm saving, and now I'm going to try it without putting in a number. All right. I'm not going to put in a number. So I'm going to run this. And if I leave it blank and click calculate, it says what the random number was, and then the program is going to blow up. All right, because the conversion did not work correctly. All right, so I'm going to make it work correctly. All right, and I'm going to change this line of code. This line of code works fine if you always know with what you're converting works. We don't know that for sure, so I'm going to change that to this. I'm going to say here, if int 32.try parse, and what do we want to do? Convert the guess, all right, and the out we're going to put into guess. And if that doesn't make any sense, we're going to go over all of it in just a second. All right, so if this works, then, well, the guess, I can come in here, let's just put it this way. I'll put a comment in here. Guess was valid. All right? So in other words, it was a number. So now I can come in here and I can say, if the guess was less than the minimum guess, or the guess was greater than the maximum guess, then I want to say txt result dot text equals that out of range. I want it to say out of range guess. And it should. All right, so that's if the guess was valid. So now we want to come in here, we want to check for out of range guess. All right, even before we do that, yep, that's fine. So that's going to handle something out of range. All right, so the guess was valid, and we want to check if it was out of range. If it was, we're going to do this. Well, first of all, let's see if that works. So another file, save all, and run the program. So I'm going to come in here, and I'm going to put in 1,000, which is out of range. The number was 53, and it says out of range guess. Perfect. All working. Clear's working. Exit's working. Perfect. So I came here and it was valid. Well, if I get down to here and it wasn't out of range, the guess was in range. So I'm going to say else if the guess is less than, all right, our random number, then what I want it to say in here is txt result dot text, and it already figured it out for me, equals too low. All right, so that means I made a valid guess, but it was too low. Else, if the guess is greater than the random number, then I want to say that it was too high. Otherwise, it wasn't too low and it wasn't too high. So otherwise, we move these curly braces back up over here. Move that there. You don't have to. You can put them in either place. All right. Now, the program isn't done, but I should be able to say txt result.text equals, and no, we don't want it to be empty, but we want it to be, let's see, what was it? It was, I don't remember, so I'll go look. It was, I didn't make one. I got too low, okay. I want guess correct. So const string guess, I'll just call it guess okay, and I'll set that equal to guess correct, exclamation point. So we'll use guess okay. Finally, we're going to put an else onto this if right here. So down here, that meant that the guess was not numeric. So I'm going to come in here and say txt result dot text equal, no, not empty. All right. Well, that we could have checked beforehand, but we want to say non-numeric guess made. So NN guess. Now, before we even start, we can come in, before we even do this, we can come in and say if there's nothing in there. So if txt guess dot text is equal to nothing, then we will just say txt result dot text equals empty, and we'll just return. Now, I'm going to go over all of this in just a moment. But believe it or not, the brunt of the program's done. So file, save, run it. All right. Now we're going to make a guess, and it's going to show us what the random number was, but I'll say 34. Calculate. It is 52, so it says guess was too low. All right, let's leave it blank. Still is going to keep showing us that. It keeps giving us a new number because we don't have it in a loop, but that's okay. No guess made. If I put in a bunch of junk, non-numeric guess, all right, and here, let's guess it correct. So, all right, so let me clear this. All right, and let's see, if I put in here 50, all right, and it's 99, it's too low. Well, that's working. Try it again, and I'll put in 100. That's going to be too high, and that's working. All right. Now, in order to be able to actually get the right guess, we're going to have to make sure we don't keep telling it to quickly give us a new guess. All right? So let's talk about what we've done so far. All right? I don't have num guesses yet. We'll put that in a second. We created up here a minimum guess. We said our minimum value we can guess is 1. The biggest value we can guess is 100. Then we said, if your guess is too low, we're going to give you that string. If your guess is too high, we're going to give you that string. If you didn't make a guess, we're going to give you that string. If you guessed something that didn't have a whole number in it, we're going to give you that string. If you guessed a number greater than 100 or less than 1, we're going to give you that string. And if you guessed it correctly, we're going to give you that string. All right. That's everything. Then we came in here and we did all this stuff. All right, this was basically saying we're able to use random numbers. This will be the guess we make. This will be our total number of guesses. All right, this will check for no input in guess text box. All right, so if we put nothing in there, we'll say it's empty and boom, we're done. All right. Now, technically, we only want to create a random number if there's something in there. So I'm going to say int rand here, and I'm not going to put a value in it. Instead, I'm going to wait, and if this was not empty, now I'm going to say rand equal, like that. Now I'm going to give it a value. So I'm only giving it a value, all right, if we actually put in a guess. All right, so I'm starting to clean it up a little bit. This will validate the guess by attempting to convert it to an integer and then checking if it is valid, which means 0 through 100, and if so, too low, too high, or guess correct. All right? So this will handle if we guess something less than 1 or greater than 100. If we get down to here, guess was between 1 and 100. So if it's less than our random number, all right, it's going to be too low. We'll tell them that. If we guessed higher than the random number, it'll say too high. And if we got the result, we'll say okay. Now, for now, I'm just going to set rand here. I'm going to set it equal. I'm just going to give it a value. So I'm going to say 50. Because otherwise, I'm not going to be able to test everything. So I'm just temporarily giving it a number. So I'm going to save everything and run it. And it says I've got errors. It says use of ambiguous. Okay. So I'll say here, I'll say it here, equal 50. All right, right there. And down here where I set it, I'll bring this back, but I'm going to comment out this line. So it is now 50. All right, the variable numGuess is assigned but never used. I'll comment that out for now. All right, that should remove any errors or anything I've got in my program. All right, so I come in here and I say 45. No, it's 50. Okay, so it was too low. I clear it and I try it again. So I come here and I say 55. All right, it shows me it's 50 again. It's too high. So now I come in, I come in again and I say 50, which is the right number. Calculate, guess correct. Everything is now working. As far as that goes, if I leave it blank, I'm getting no guess made. If I do an out of range number, it says guess out of range guess. So everything in there is working right now. So what I have to put in is first I have to count the number of guesses. All right. And I'll show that later as a message box. We could put it in here if I made this bigger. All right. In fact, yeah, that's fine. We can do that. So guess correct. All right. And not much more. Then we can go in and start adding multiple games. All right. So let me exit from here. And again, because I'm a little anal this way, as I've shown you before, I'm going to make this centered. So I'm going to go to text align and set it to center. That's the first thing. Everything else looked fine the way it was as far as I could tell. So the problem that we have right now is if we take this out, all right, if we take that out and we take this out, if we take those two things out, it's going to keep every single time giving us a new random number, and we don't want that. All right, so what I'm going to do, and there's multiple ways of doing this, is I'm going to create a Boolean variable. All right, so I'm going to make another variable in here, a bool that's called correct number guessed. All right, and I'm going to set it equal to false. Okay, so I only want to do this. All right. So as long as the guess was not correct, so I'm going to say while guess correct, what do we call that? Correct guess, sorry. While correct guess, then I want to do this. So every time I've guessed correctly, this is going to call this to create a brand new random number. All right. That'll allow me to keep doing this. All right, now, if I get down to here, validate the guess. If I get down to here, the guess was correct. All right, so if I get down to here, the guess was correct. All right, and there's probably a better way of doing it than I'm doing it right now, but I'm going to say numGuesses plus plus, and I don't like to repeat my code, but I'm going to put that there. And I'm going to put it here, and I'm going to put it here. All right, so now I've got all my guesses. All right, and this was the guess okay. I don't want that there. So when it's okay, I'm going to print out a message box that says number of guesses, and we will give it num guess, num plus num guesses. All right, and that'll be the text that's in there. And my title will be U1. All right, and I will put in here my message box buttons, and I'll just put in an OK button. That's the one I want here. And finally, I want my icon, and it'll just be an information. All right, hopefully I set that up okay. If I screwed up with something, system as it is there is going to let me know. Oh, I don't want icon there. I want that to be button. Well, it doesn't like that, so let me try it again. It's buttons. There we go. Dot. Okay. All right. Paren, I'm still giving me an error here. Oh, I need a message box dot show. All right. All right. So let's try it again. I'm going to make a guess. In fact, I should be actually generating the random number first, but that's okay. So 50. So let's just, it says our guess was too low, so we have one guess. 60 says it was too high, and we have one guess. Good. 50. So we've made 3 guesses. Guess correct. Number of guesses is 1, so that isn't working, but we'll fix that in a minute. So guess correct. So everything other than that's working, and we're getting our box up. But what is happening is, yes, I want to exit. All right. Our number of guesses isn't working because it is being reset every time we get in here. We don't want that. So I'm going to remove that from here, and I'm going to move that out to here and see if that works. I'm going to need the word static here. I showed you that before. Let's see if now it works. So the other thing I'm going to do is I am going to generate the random number. Well, it is 50, so that's fine. I'm not going to show what the number is, so I'm not going to give my little hint there. All right, so I'm going to run the program, and we'll put in 50. All right, number of guesses, we won. All right, guess correct. Well, I didn't want that, so let's try it again. It's 50 because we made it 50 here. I forgot about that. But we'll do it again. So let's do 40. Guess was too low. Good. All right, let's clear. Let's do 60. Guess was too high. Good. Let's do 50. Guess correct. Number of guesses is now 3. That's what we wanted. So as long as we didn't break anything, so, whoops, number of guesses 4. Well, I can keep guessing, I guess. I should reset that, but that's not a problem. With nothing in there, it says no guess made. With something non-numeric in there, it says non-numeric guess. With a guess that's out of range, it says, oh, it said non-numeric guess. It really shouldn't have done that, so let's try that again. Well, I think it's the minus sign, so let's try that. Huh. It's saying non-numeric guess when I'm putting in a big number. So if I put in 555, out of range. All right, it must be when I reach a certain level. So basically, it is working now. A couple more things we have to change. All right, so let's see. Now, once we guess it, we want to make sure we set this equal to true because that'll generate a brand new random number for us. All right, so that'll set that. We also want to reset our number of guesses back to 0 because we just, oh, not correct, correct number guessed. We want to set that equal to true. All right. So again, play computer here and figure out everything that's happening. we originally come in and set our random number to 50. We're going to guess. We have not yet guessed the correct number. We could put this out there to show us whenever we generate a new random number what it is. I'm going to leave that off. All right. So if it's empty, we just say, hey, you didn't make a guess, there's nothing in there, and we return. Otherwise, as long as that thing is set to false, all right, or I'm sorry, until that becomes true and it's false, so while that's true, all right, so when this becomes true, okay, then we want to call this. And so since we want to do a random number, the next thing we want to do is we want to make sure that our correct number guessed is set to false, but we don't put it in an infinite loop. All right, so now we come in here and we start validating. If we get down to here, we put in a number. This says, grab what's in here, attempt to parse it or convert it into an integer value, and put the result in guess. If it works, guess now holds the number we put in. If it's less than 0 or it's greater than 100, it should say out of range guess. Otherwise, if it was a number between 1 and 100. But if it's less, so if it's 50 and we put in 40, it should say guess too low and add 1 to our guesses. All right. If it's 50 and we put in 60, it should say guess too high and again add 1 to our guesses. So we've checked the too low and the too high. So again, I'll put a comment here that says guess too low. I'll put another comment here that says guess too high. And I'll put another comment here that says guess correct. So when it's correct, we want the OK message. It was a guess, so we want to increment our number of guesses. We want to put up the message box that shows the number of guesses we had. All right, we want to make sure that our text box says that it was correct. We want to set our number guessed to true, so when it comes back in here again, it generates a new random number. And we set our number of guesses to 0, so we start all over again. Finally, if what we put in here originally, if this does not work, if we couldn't parse it, we're going to put in non-numeric guess. And I believe that's everything. All right? Now, I made this much, much, much harder. I probably should have used the one in the book. And if your head's spinning right now, what I'm going to do is give everybody a copy of this. But actually, it's a good program in that it shows a lot of the stuff we've covered. It does generate a random number. All right, so if I put in here 34, it's 50 to begin with, so it was too low. All right, and if we clear and I put in 50 and I click calculate, it was correct. But now if I click clear again and I put in 50, oh, so it's resetting it, and I don't want it to do that. So let's see, because it's resetting it right here into false. I did reset it here to true, but it's being reset. I'll tell you what, it is 10:24. I'm not sure exactly how long we've been going now, but it's been close to an hour. Let me fix this up. We'll take another 10-minute break till 10:35, and I'll come back at that time and finish this up. Trying to fix this up, so let's see if I have. I don't know if I have or not. So, all right. Now if I put in a different random number or a different guess that's not 50, so 35. Random number general. Okay, it's telling me that I put that thing back in, so that's the number. So guess was too high. That's good. It did generate a 4, so I can clear. If I put nothing in, that's an invalid guess, so it shouldn't count. So I've only made one guess. If I put in something non-numeric, all right, That shouldn't count, so I've still only made one guess. If I do an out-of-range guess, all right, that shouldn't count, so I'm still at 1. Another, again, out-of-range guess. All right, boom, I'm okay, so I'm still at 1. So let's put in 20. It's too high, fine. Let's put in 10. Too high, that's like about 3 or 4 guesses. 5, still too high. Let's put in 3. That's too low, that's all working now. And let's put in 4. So it says we had 6 guesses and our guess was correct. We could have just said change this and put the 6 guesses in here as well. That would be fine. Now, I should have called clear there and I didn't, but our number was 4. And you'll notice it's generated a new random number, which is 23. All right, so our guess was too low. So it is now working. I went back because we haven't talked about loops yet. So I wanted to write this or kind of do some rewriting that didn't include loops. So what I'm going to do here is I'm going to take about a half an hour at the most, and I'm going to redo this or go over this again, all right, and get rid of things I don't need, comment where I should comment, etc. I made everything global in here because it made it easier. I didn't have to worry about passing things. I still have my constants up here. All right? So again, I've got my constants for the minimum guess and the maximum guess and all of my different error messages and my correct message. All right? Then these are my global or basically program variables. The number of guesses, like I said, so I didn't have to pass it around. That's the total number of guesses. This is the current guess. This will be our random number, and notice now it's not set. This will be whether or not our guess was correct. I'm just going to change that to guess made. There. All right. So, as we're running our way through this, oops. All right. We first start out by, this is called instantiating the random number class. All right, so we're able to use what's in there. Fine. Now, with this, I don't need this because I don't have it in there anymore. So this can be totally gone. The first thing I do is I check to see whether or not that text box was empty. So this right here will check to see if this right here has nothing in it. If this right here has nothing in it, it will fill up this right here with a message that says no guess made, because there was nothing in there. All right? And what I should do, just because it's a string method and it allows me to do it to you, is I can say txt guess text dot trim. That's one of the string methods that'll remove any blank spaces that we put in at the beginning or at the end of something. So I've trimmed it first. So again, if after I trim it there's nothing in there, I'll say no guess made. And I return. I'm done. There's nothing else to do in here. So if this gets hit, if this is true, it doesn't go through any of the rest of the program. All right? But what I want to do, though, is I say if correct guess, and notice I changed that. I set it to true because now what I want to do is start a new game. But I don't want to keep starting a new game, and if I don't reset correct guess to false, I will keep starting a new game because it's true. So I call start new game, and I immediately set correct guess to false in there. All right, so I call start new game, and that is a simple routine that does this. Where are you? There it is. It generates my random number. So I'll put comments in here. Generate random number from 1 through 100. So that's first thing. Assumes not number not yet guessed. Well, since it was just generated, it'd be a pretty good assumption that it wasn't guessed yet. and no guesses yet made. All right? So I've got this in here twice. I don't know why, but it's generating it twice. So it's generating that. I can get rid of this one because it's the same statement. And now let user know number has been generated. Now I'm going to change this to random number generated. And I'm going to check that that's my text. And I'm going to say, got new number. All right. Now when I play this, it won't actually show me what the number is. So I come in here and I make a guess. Another thing that I can do, because you haven't seen this before, but you might as well, is I can take this. I really shouldn't be allowed to make a guess until I've generated a number. All right. So I'm going to come in here, and where it says there's a property called enabled, I'm going to set it to false, which means that when I run the program, I can't click in here. You'll notice it's gray. But once I've generated the number, so once I have generated the number in here, and I've started a new game, now I want to say that text box txt guess text dot enabled is true. All right, and if you say, oh, geez, I don't know what you just did, I'll put a comment here that says enable guess text box, and then let's run the program. All right, so notice it's disabled. I can't come in here and make a guess. But once I click calculate, all right, it does say no guess made, which isn't good. But when I clear, well, I guess now it's not doing it right away, though. All right, so let's see. This is the problem with not doing this ahead of time, so sorry about that. So I made there I've done that, and I should be able to enable it here. Let's see if that works. All right, click calculate. No, there was no guess made, so it's still running that. So let's see. It should have, at the beginning, it should have come in here and said, if correct, guess, and it should be true. So it should be calling this routine here. Start new game. So start new game and set it to false. That is correct. So let's put a message box in here. Calling start new game. And I don't even worry about there being a heading, so I'll just leave the heading blank. All right, we'll see if this works. Should be calling that now, and it's not. So something is goofed up in my logic. This is what I'm going to do. I'm going to fix the program, and I'm going to rewrite it again so you will have it both as a console program, which I didn't do yet, and as a GUI program. All right? So let's go back and do this. That is, let's take a look at what homework we're going to have, because your homework and your test are much, much, much easier than what I just did. I actually did way too difficult of a program right now for where we are in the class. All right? But let's take a look at what we have in here. So here are our labs. Nope. Here are our labs and our homework. So chapter 4 homework, we will again, now we'll have two problems. Calculate area and perimeter and accumulate test score. So we will have to build this, where we will come in and say, enter a length and enter a width, multiply one by the other, and that'll give us our area. And then we have our perimeter. All right, I don't remember what the formula is for that, but it's in there. 2 times the length plus 2 times the width. So 2 times 25, which is 50, plus 2 times 100, which gives us the 250. We'll add a clear button in here, and that'll be it for that one. And then accumulate test score. Well, this one is more similar to what was at the end of the chapter. So I'm going to have you, for the first time, you will work on this one on your own. All right? We will do this one tomorrow as a class. When I'm doing that as a class, I will not tape that using Camtasia, so it will not be on YouTube. It will only be under the Teams meeting for our class. So that will be the homework. John, are you there?
Yes, I'm here.
Okay. So hopefully what I just said makes sense. All right. And then in our labs for chapters 4 and 5, so let me open those. Tomorrow we're going to go over chapter 5 as well, but let's look at these. So this will be the lab for chapter 4. And it looks like there are 3 problems, 2 or 3, I don't know. We'll look though. All right. And it's got this college admission thing. That's fine. Maybe we'll do this one with wind speed. I don't know. And this is another generate. Oh, this is rock, paper, scissors. All right. And I'll see if I can find mine. We'll do a simple one like this. That's the one we'll do. So we'll do the rock, paper, scissors as a class. And I'll show you the one that I made, which is, I kind of went nuts with it a little bit. So that's the chapter 4 stuff, I believe. Or maybe I gave you the chapter 5, I don't know. And I guess I did. So that is the chapter 5 labs I just showed you. And from the chapter 4 labs, that's different. So let me make this bigger so you can see it. You are to convert miles to kilometers. We've already done that, but go back and forth. All right, here's a chicken and an egg farmer. Here's that thing again with the payroll projections. So we'll pick out one of those. Maybe we'll do the chicken farmer. So when we start tomorrow, the first thing I'm going to do for the first 1/2 hour to 1 hour is I'm going to redo the test for everybody. I'm going to pretend I'm a brand new student who's going to redo the test. All right? And after I do that, if it takes closer to an hour, that's fine. But I don't think it will. I think we'll be able to do that in about a half of an hour. So then we will come in here and we will do, again, probably this chicken farmer one. And from here, the rock, paper, scissors one. And from here, I'll just do those. Then we'll go through chapter 5 and, oh, I guess I'll do this problem too, the calculate, this accumulate test score. Then we'll go through chapter 5 and we'll also do one of these. There's a factorial here and a calculate change and an income tax. So you'll have enough homework. All right, but we will do one of the homeworks from chapter 4, one of the homeworks from chapter 5, one of the labs from chapter 4, one of the labs from chapter 5. Now, you're my only guy here, I believe, John, so is what I'm saying make sense?
Yeah, it makes sense.
Donald, are you there too?
Here.
You're
Yeah.
there, Donald? Okay. Does what I'm saying make sense?
Yeah.
Okay.
So for our chapter 4 homework, it's the calculate area and perimeter, right?
So for chapter 4, let's go back to that. When we look at this, you'll have to do all the stuff for chapter 4 and all the stuff for chapter 5. So for chapter 4, it'll be this, calculate area and perimeter, and it'll be this, but we'll do that one as a class. So you'll have to do that one on your own. If you have questions while you're doing it or something doesn't seem to be working, that's when you email me, and if I have to, I have a Teams meeting with you. Then for chapter 5, this one is not easy. the factorial. So maybe we'll do that one, I don't know. But the change one, this one isn't hard. I'll give you a hint on how to do it. And the income tax, again, is not that hard. It's a little laborious because it's a bunch of if statements. Okay, but we'll do one of those for chapter 5. Okay, so that'll be the homework. Then for the labs for chapters 4 and 5. For the lab for chapter 4, you will do this distance converter, and you've already done one almost identical to it, except you didn't go back and forth. You'll do that one on your own. We'll do the chicken farmer one together, and you will do this one right here that's got the payroll projections. You will do that one on your own. All right? Then for chapter 5, the college admission one I'll let you do on your own. The wind speed one we may or may not do, we'll see. But the rock, paper, scissors one we'll do together. All right? Did I answer your question? Does that make sense as far as the homework? I'll repeat this tomorrow.
Yeah, that makes sense.
Okay.
And then, so is all that the homework in the labs due this Sunday?
No. The chapter 4 and chapter 5 homework will be due a week from Sunday.
Okay.
All right? And just so you know, again, tomorrow is Thursday. No, tomorrow is Friday, I guess, right? No, what day is today?
Today's Thursday.
Today's Thursday. Good. So tomorrow we'll get through chapter 5. Let's pretend that tomorrow there is no time left. We've gone through everything and there's no time to do the lab and the homework. If that's the case, we'll spend Monday doing that. Then Tuesday, what's going to happen is I am going to sit here at the computer for 4 hours, and I'm going to give you an entire period, lab period, to work on this. And if necessary, I'll give you 2 lab periods. Then we will have another one of these pre-tests, which again, you won't have to turn in, but I'll go over it with you. And then probably, a week from tomorrow, you will have your next hands-on test. Does all that make sense? We'll see. We may have to adjust the days, but does what I'm saying make sense to everyone?
Yes, sir.
Yes.
Okay. So what I'm going to do right now, because I've just thrown way too much stuff at you, is I'm going to call it a period. All right? So what I'd like you to do, I mean, it's not a homework assignment or anything, but start to look through the Chapter 4 homework, start to look through the Chapter 4 labs, and see if you have any questions. So when I start going over and we do the ones as a class, you can say, hey, I know that we're doing this one on our own, but I've got a question about this. Or I know that we're doing, this one on our own, but I've got a question about it. And you can ask, all right? Because then I can answer it right away, and I think that'll make it easier for all of us. And the same thing with Chapter 5, and the same thing, so for those are for the labs, and the same thing for the homeworks. All right? So if nothing else, if you spend a half an hour going through that quickly and say, no, that seems like it makes sense, that's okay, fine. But tomorrow, like I said, first thing, on the Microsoft Teams tape, but not taped with Camtasia, so not on YouTube, I'm going to redo test number 1 for everybody. All right? And I'm going to show you how you can save it and email it to me. I'm going to show you how you can save it and put it out on a repo. I'm going to do all that. Then we're going to jump right into Chapter 5. All right? And there are programs in Chapter 5, a few of them I want to look at. That may take between those two things most of the period. Let's pretend it does. Let's say that it's right around now, around 11 o'clock. So then what I'm going to do is explain again what your homework is, what your labs are. And then we'll plan on doing that. Then on Monday, Monday I will go over one or more Chapter 4 labs, one or more Chapter 5 labs, one or more Chapter 4 homeworks, one or more Chapter 5 homeworks. We'll do that Monday. Tuesday, and Wednesday
Do
will...
we have school Monday?
Oh, you're right. You don't have school Monday. All right, we'll just push it off a date. That's good. Thanks for reminding me. So, Monday, you're right. We don't have school. So let's plan on Tuesday of next week. We'll spend the whole period, or however much time it takes, going over Chapter 4 and 5 homework and labs as a class. Wednesday and Thursday will both be labs, all period. I will be online, but I'll just have like a screen like this up there. If you have questions, you can ask me, you can email me, and I'll try to answer them right away. Or you can ask me right in Teams. I'll keep the Teams session open. All right? So then we'll do that on Wednesday and Thursday. Friday will be a pretest, which I will give you. It'll have 2 problems on it. They will both be GUI problems, so you'll make a Windows form with both. And then a week from Monday, which is the 24th, will be your next test. That may not jive completely with what I have on the syllabus, but that's the way that we'll set it up. Thank you for reminding me of that, John. Any other questions anybody has? Donald, or John, or if Michael, if you are there, anybody else have any questions?
No, I'm good.
Okay.
Yeah, so with our GitHub, the Chapter 2 and 3 homework is on there, and then our labs, my lab is on there too, so that would mean it's turned in, right?
Yes, that's already been turned in then. Yeah, and
Okay.
that stuff I'm going to grade this weekend. It's not due till Sunday, but everybody who's got it in by Sunday, I'll grade it. You technically have until midnight Sunday, so going into Monday morning. So whatever isn't turned in by then, I go to bed by 10 o'clock, but whatever's not turned in by then, all right, then I won't grade that. I won't grade it till the next day, all right? But the stuff that you're going to be working on next for Chapters 4 and 5 will not be due until the 23rd. So the night before, you have the test on it. Did I answer your question?
Yes.
Okay. Well, if there are no more questions, again, it's early, but I've thrown a lot of stuff at you. I'm going to go in myself between now and 12, and I'm going to fix this program that I had for you, and it will work and it'll be right. And then I'm going to grab it and make it into a console, all right? And I'm going to take that and I'm going to put that out there and email that, or in fact, I'll put it out there as a public repo, and I'll give you all the address to that, all right? So I will see you then tomorrow. Have a good rest of the day.
Sir,
Yes?
you should be able to send an email with the video of this recording, or
I will send
Sir.
you an email that immediately when this is done on Teams, I will send you that link. And then my class, I've got a lecture for an hour today, probably from about 12 to 1:30. When that's done, then I will take the Camtasia presentation and I will produce that. And by the time that gets produced, I'll be able to email you or give you the GitHub for all that stuff. I will email you the links to everything, yes.
okay, thank you.
All right. All right, if that's it, then see you tomorrow.